What if everything you've heard about alien visits is not just unproven but practically impossible? There's a belief that keeps showing up again and again in movies, in late-night conversations, and even in serious discussions. The idea that alien civilizations have already visited Earth or are secretly visiting right now, that flying saucers have landed in remote areas or military bases, that humans have been abducted and studied, that governments are hiding the truth to prevent panic, that crashed alien spacecraft have been recovered and analyzed behind closed doors. This belief isn't rare. Surveys consistently show that somewhere between 20% and 40% of Americans think extraterrestrials have visited Earth. Thousands of UFO sightings are reported every year, and many people are convinced these objects are not natural phenomena or human-made machines, but real alien spacecraft. And this idea hasn't stayed limited to the general public. It has reached serious institutions. The Pentagon has released videos of unidentified aerial phenomena. Congress has held hearings where military personnel describe encounters with objects that seem to defy current understanding. These are not random claims, they come from trained observers. But here's the part that most people don't expect to hear. Aliens have never visited Earth, and they never will. Not necessarily because they don't exist. Maybe they do, maybe they don't, but because even if intelligent civilizations are common in the galaxy, the reality of physics and biology makes visiting Earth almost impossible. The distances are too vast. The energy required is enormous. The window of time during which civilizations are advanced enough is surprisingly short. The chances of Earth being specifically targeted are incredibly low. And most importantly, alien life would almost certainly be incompatible with Earth's environment. We are not being visited. We have not been visited. UFOs are not alien spacecraft. And the reason isn't some massive government cover-up or lack of alien interest. The reason is much simpler and much harder to ignore. It's basic physics and biology. Interstellar travel to Earth is just as impractical for them as it is for us. And even if they somehow managed it, Earth itself would be a dangerous and hostile place for any organism that didn't evolve here. The idea that Earth would kill them isn't exaggeration. It's a biological reality. Our planet's biosphere is the result of nearly 3.8 billion years of evolution. Every organism here is finely tuned to very specific conditions: our gravity, our atmosphere, our chemistry, our radiation levels, and even our microscopic ecosystem. Any alien life form coming from a completely different world would face immediate threats just by being here. The environment alone could kill them within hours or days unless they had technology that completely isolates them from Earth. And if they're fully isolated, then they're not really visiting Earth in the way people imagine. They wouldn't be walking around, interacting, or exploring freely. They would be sealed inside protective systems, observing from a distance. That doesn't match the stories of UFO encounters or alien abductions. Now, to be fair, we need to be precise about what we're evaluating. There are different scenarios people imagine when they talk about alien visits. Some are more extreme than others. But the most common one, the one most believers talk about, is this. Aliens travel across interstellar distances in physical spacecraft, reach Earth, operate within our atmosphere, or even on our surface, interact with the environment or humans, and then leave, either returning home or hiding somewhere in our solar system. This scenario sounds simple when described like that. But in reality, every single step in that process faces massive challenges. Challenges that are either completely impossible or so unlikely that the overall probability drops close to zero. And that's exactly what we're going to break down step by step. Because once you understand these barriers in detail, the mystery around alien visits starts to disappear, not because it's being hidden, but because it was never realistic to begin with. And the first barrier we need to confront is the biggest one of all: distance. Distance is not just a challenge, it's the kind of obstacle that quietly destroys the entire idea before it even begins. To understand why, we need to step outside our everyday sense of scale. Space is not like traveling between cities or even across continents. The distances between stars are so enormous that even our fastest spacecraft barely make a dent. The closest star system to us, Alpha Centauri, is about 4.2 light years away. That means even light, the fastest thing in the universe, takes over 4 years to get there. Now imagine a civilization trying to travel not at the speed of light, but at something much slower, because according to everything we know about physics, faster than light travel is not possible. Even if we imagine extremely advanced propulsion systems, like nuclear fusion rockets or antimatter engines, the best-case scenario might reach about 10% of the speed of light. At that speed, a journey from a relatively nearby star system, let's say 100 light-years away, would take around 1,000 years. Think about that. A single trip would last longer than most human civilizations have existed. During that time, the spacecraft would need to remain fully operational. Every system, life support, navigation, communication would have to function perfectly for a millennium. If the travelers are biological beings, they would need a way to survive that entire journey. Maybe through suspended animation, which we don't even know is truly possible, or through generational travel, where entire societies live and die aboard the ship over centuries. Both options come with enormous biological, social, and technical risks. And that's just survival. Navigation is another problem entirely. They would have to aim for Earth with extreme precision from dozens or hundreds of light years away, based only on distant observations. They would be targeting a planet they've never visited, using data that is already outdated by the time it reaches them. If they are 100 light years away, they are seeing Earth as it was 100 years ago. In other words, they're not even traveling to the present, they're traveling toward a version of Earth that no longer exists. Everything could have changed by the time they arrive. The environment, the atmosphere, even the presence of intelligent life could be different. It's an enormous gamble, and the payoff is completely uncertain. Now consider the energy required for this journey. Accelerating even a modest spacecraft to 10% of the speed of light would require an amount of energy comparable to the total energy output of an entire civilization over years, possibly decades. And that's only for acceleration. They would also need energy for deceleration if they want to actually stop near Earth instead of just flying past it. On top of that, they need continuous energy for life support, onboard systems, communication, and course corrections throughout the journey. Then there's fuel. Because of the way rocket physics works, carrying fuel becomes a massive burden. The more fuel you carry, the more mass you have, which requires even more fuel to move. This creates an exponential problem. To make a journey like this, they might need thousands or even tens of thousands of times more fuel than the mass of the spacecraft itself. And that fuel would need to be stored, managed, and kept stable for centuries. Even for a highly advanced civilization, this is not a small project. It's an enormous, risky investment with no guaranteed return. And after all that, after 1,000 years of travel, massive energy costs, and extreme risks, they finally arrive at Earth, a planet that, from their perspective, looked interesting 1,000 years ago. Would any civilization realistically commit to something like this? Only if the target is incredibly valuable. But Earth isn't particularly special. It's a typical planet orbiting an average star in an ordinary part of the galaxy. There are billions of similar stars, many with planets of their own. From a cosmic perspective, there's nothing about Earth that stands out as uniquely worth such an extreme mission. The only thing that might attract attention is life, especially intelligent life. But here's the catch. The only way a distant civilization could know we exist as a technological species is by detecting our radio signals. And those signals have only been traveling through space for about 100 years. That means only civilizations within roughly 100 light years could even be aware of us. Anyone farther away wouldn't even know Earth is inhabited by intelligent beings yet. So now the odds shrink even further. Not only does a civilization need to exist, it needs to be close enough to detect us, advanced enough to attempt interstellar travel, and motivated enough to invest in a journey that takes centuries or longer. And even then, the risks remain enormous. If we extend the distance to something like 1,000 light years, which is still a tiny fraction of the galaxy, the travel time jumps to 10,000 years at 10% the speed of light. That's longer than recorded human history. And again, they wouldn't even know we exist, because our signals haven't reached that far yet. So most potential alien civilizations, if they exist at all, are too far away to detect us and too far away to reach us. They would be searching blindly among hundreds of billions of stars. And the chance that they would randomly choose Earth out of all those possibilities is incredibly small. When you combine the sheer difficulty of the journey with the low probability of selecting Earth as a target, the idea of alien visitation becomes not just unlikely, but extraordinarily improbable. And we haven't even touched the most decisive barrier yet. Because even if a civilization somehow solved all of these problems and actually made it here, there's another issue waiting for them. One that doesn't just make the visit difficult. It makes survival itself almost impossible. Even if we imagine, for a moment, that an advanced alien civilization somehow overcomes the impossible distances, solves the energy problem, and survives a journey that lasts centuries or even millennia, there's still one final barrier waiting for them the moment they arrive. And this one isn't about engineering, it's about survival. Because Earth is not a neutral environment. It's not a blank, welcoming world ready to be explored by any form of life. It is a highly specialized ecosystem shaped by nearly 3.8 billion years of evolution. Every organism on this planet, from bacteria to humans, is deeply adapted to very specific conditions. Gravity, atmospheric composition, pressure, temperature, radiation, and even microscopic life. All of it works together in a delicate balance. And anything that didn't evolve here would be completely out of place. Let's start with gravity. Gravity feels normal to us because we evolved under it. But for an alien species, it could be a serious problem. If they come from a low-gravity world, even standing on Earth could be physically overwhelming. Their bodies might not be built to support their own weight here. Muscles and bones could fail under the pressure. Their cardiovascular systems might struggle to circulate fluids properly. What feels normal to us could feel crushing to them. On the other hand, if they evolved on a high-gravity planet, Earth might feel too weak. Their movement, balance, and coordination would all be off. They might not function properly in an environment where their bodies are no longer under the conditions they evolved to handle. Now consider the atmosphere. Earth's air is roughly 78% nitrogen and 21% oxygen, with a pressure level that suits life as we know it. But there's no reason to assume alien life would breathe oxygen or even tolerate it. For them, our atmosphere could be toxic. Breathing Earth's air might be like a human breathing chlorine or ammonia. Even slight differences in pressure or gas composition could cause immediate harm. Temperature is another issue. Life on Earth operates within a relatively narrow range. Outside of that, things break down quickly. An alien species might come from a world that is much colder, much hotter, or far more stable than Earth's changing climate. Exposure to our environment could lead to rapid overheating or freezing. Radiation adds another layer of risk. Earth is protected by a magnetic field and an ozone layer that shield us from most harmful radiation. But alien life might be adapted to completely different levels of exposure. They could be more sensitive or in some cases, less. Either way, the mismatch creates uncertainty and danger. And then there's the most overlooked factor of all, microorganisms. Earth is full of them. Trillions of bacteria, viruses, and fungi exist everywhere on surfaces, in the air, inside our bodies. They have evolved to exploit every possible niche. Any new organism entering this system would instantly be surrounded by life forms trying to interact with it. Now, it's true that alien biology might be so different that Earth microbes can't infect them in the traditional sense. But that doesn't mean they're safe. The real risk is unpredictability. Their immune systems would have no experience dealing with Earth's biology. And Earth's microbes might still find ways to break down or interact with alien tissues in unexpected ways. This flips the common idea you see in stories like the War of the Worlds, where aliens are defeated by Earth bacteria. In reality, the situation is more complex. It's not just about infection, it's about complete biological mismatch. Even without direct infection, chemical interactions, environmental exposure, or microscopic processes could damage them in ways they are not prepared for. So what would aliens need to survive here? Total isolation. They would need sealed environments, protective suits, controlled atmospheres, essentially bringing their home world with them. Just like humans need spacesuits to survive on the Moon or Mars, aliens would need full protection to survive on Earth. But this creates a new problem. If they are completely isolated, they are no longer truly interacting with Earth. They are observing it through layers of protection. They wouldn't be walking freely, touching surfaces, or breathing the air. They would be locked inside control systems at all times. And maintaining that level of isolation is incredibly difficult. Any small failure, any leak, any system malfunction could be fatal. It requires constant energy, constant monitoring, and extremely reliable technology. At that point, you have to ask a simple question. Why come down to the surface at all? If you're going to stay sealed inside a protective system, you could do the same thing from orbit, or even from a distance using advanced sensors. There's no real advantage to physically landing on a hostile planet if you can't interact with it directly. Which brings us to a crucial conclusion. Even if aliens could reach Earth, they couldn't safely operate here without extreme measures that reduce the value of the visit itself. And that leads us to the next question. If it's so difficult, so risky, and so costly, why would they come here in the first place? Once you understand the scale of the journey and the danger of the environment, the next piece of the puzzle becomes even more important. Motivation. Because no civilization, no matter how advanced, commits to something this extreme without a strong reason. Interstellar travel, as we've seen, demands enormous energy, long time frames, and serious risk. So what would make Earth worth it? To answer that, we need to zoom out and look at the bigger picture. Our galaxy, the Milky Way, contains between 200 and 400 billion stars. Earth orbits a fairly ordinary star in a quiet region of this galaxy. There's nothing visually or structurally unique about our location. From a distance, we don't stand out. So why choose us? If an alien civilization is deciding where to send a mission, they have billions of options, countless stars, countless planets, many of which could be easier to reach or more interesting based on their own needs. The only feature that might make Earth special is life, and more specifically, intelligent life. But as we've already established, detecting that intelligence is not easy. Our radio signals have only been spreading through space for about a century. That means only civilizations within roughly 100 light years could even know we exist as a technological species. And even among those nearby stars, the chances of finding a civilization that is both advanced enough and interested enough are extremely small. For everyone else, Earth is just another planet. Now, let's consider possible motivations. First, resources. Maybe aliens want something Earth has: minerals, water, or other materials, but this doesn't hold up. The same elements found on Earth exist throughout the galaxy. Asteroids, moons, and uninhabited planets contain vast amounts of resources that are far easier to access. There's no need to travel hundreds of light years to extract materials from a living planet with a complex biosphere. From an economic standpoint, it doesn't make sense. The energy required to travel that far would far exceed the value of anything they could take back. Next, colonization. Maybe they're looking for a new home. But Earth would be a terrible choice. As we discussed earlier, our environment would likely be incompatible with their biology. To live here, they would either need to terraform the entire planet, destroying our ecosystem in the process, or live in sealed habitats. And if they're capable of building sealed habitats, they don't need Earth at all. They could construct those environments anywhere closer to home with fewer risks and lower costs. Then there's the idea of conquest. This is common in science fiction, the idea that aliens might invade or eliminate humanity. But when you think about it logically, it falls apart. We are not a threat to a civilization that can travel between stars. We don't compete with them for resources. We don't have the ability to reach them or harm them. There's no strategic advantage in attacking us. Some theories suggest civilizations might act out of fear, destroying others before they become threats. This idea is sometimes referred to as the dark forest concept. But even this doesn't work well in practice. Interstellar attacks would take so long to execute that they wouldn't function as effective preemptive strategies. By the time an attack arrives, the situation could be completely different. So what's left? Curiosity. Maybe they just want to explore, to learn, to observe other forms of life. This is the most reasonable motivation, but even here, physical visits are not the best option. Sending robotic probes, using remote sensing, or observing from a safe distance would achieve the same goals at a fraction of the cost and risk. There's no clear reason to send biological beings into such a dangerous and inefficient mission. And when you combine all of these factors, the difficulty of travel, the biological incompatibility, the lack of strong motivation, the conclusion becomes unavoidable. Alien visitation is not just unlikely. It's effectively ruled out by the realities of physics, biology, and logic. But that still leaves one important question. If aliens aren't visiting Earth, then what are people actually seeing when they report UFOs? If aliens aren't visiting Earth and everything we've examined strongly points in that direction, then we're left with a different question, and it's just as important. What exactly are people seeing when they report UFOs? Because these sightings are real, in the sense that people genuinely observe something unusual. Thousands of reports are made every year. Some come from ordinary individuals. Others come from trained pilots, radar operators, and military personnel. These are not people who are easily dismissed. So what's going on? The key point to understand is this. An unexplained observation is not the same as evidence of extraterrestrial technology. It simply means we don't have enough information to identify what was seen. And in most cases, when we do investigate carefully, the explanation turns out to be something entirely ordinary. Studies consistently show that around 90% to 95% of UFO sightings can be explained once enough data is available. These explanations are often simple, but under the right conditions, they can look very strange. For example, aircraft lights at night can appear to hover or move in unusual patterns, especially when viewed from a distance without clear reference points. Satellites reflecting sunlight can suddenly brighten or fade, creating the illusion of controlled motion. Planets like Venus are often mistaken for moving objects because of atmospheric distortion. Weather balloons, drones, and even birds can appear unfamiliar when seen in poor lighting or at unusual angles. Small objects close to a camera lens like insects can look like fast-moving objects at great distances. Optical effects, such as lens flares or reflections, can create shapes that seem structured or metallic. Then there are atmospheric phenomena. Rare events like ball lightning, unusual cloud formations, or temperature inversions can produce visual effects that are difficult to interpret in the moment. On top of that, there are human factors. Our brains are excellent at recognizing patterns even when none exist. This tendency, known as pareidolia, causes people to interpret random or unclear visuals as familiar shapes or objects. In low visibility conditions, the brain fills in gaps, often creating something more structured than what is actually there. Memory also plays a role. Over time, details can shift. observations become less precise. Stories evolve, especially when influenced by media or discussion with others. And then there are cases involving classified technology. Military tests and experimental aircraft are not always publicly disclosed. When people encounter something that doesn't match known technology, it can appear mysterious or even impossible. But that doesn't make it extraterrestrial. It just means the information isn't available to the public. Now, what about the remaining 5% to 10% of cases that remain unexplained? This is where many people jump to conclusions. But unexplained doesn't mean alien. It simply means there isn't enough reliable data to reach a conclusion. Maybe the observation was too brief. Maybe the conditions were poor. Maybe the data is incomplete or contradictory. In any large set of observations, especially those made under uncertain conditions, it's normal for some cases to remain unresolved. What would be unusual is if every single case had a clear explanation. And here's the most important point of all. Despite decades of sightings, investigations, and claims, there is still no solid physical evidence of extraterrestrial visitation, no verified alien materials, no confirmed spacecraft, no biological samples, no clear, unambiguous images or videos that cannot be explained by known causes or deliberate fabrication. If aliens were truly visiting Earth regularly, landing, interacting, operating in our skies, we would expect something far more concrete by now. Clear evidence, repeatable observations, physical proof that holds up under scientific scrutiny. Instead, what we have are blurry videos, uncertain testimonies, and cases that dissolve under closer examination. That doesn't mean people are lying. It means human perception is limited and unusual observations can be misleading. And when you combine that with the overwhelming physical and biological barriers we've already discussed, the simplest explanation becomes the most reliable one. UFOs are not alien spacecraft. They are misunderstood phenomena. And that brings us to the final piece of this entire discussion. Because once you remove the idea of alien visitation, something interesting happens. The mystery doesn't disappear. It changes. When you step back and look at the full picture, the conclusion becomes difficult to avoid. Not because of belief, but because of constraints. The universe operates under rules of physics, rules of biology, limits on energy, distance, and time. And those limits don't just apply to us. They apply to any civilization, no matter how advanced it might be. Interstellar travel is not just hard, it is overwhelmingly demanding. The distances alone stretch missions into centuries or thousands of years. The energy requirements are extreme. The risks multiply over time. And even if all of that is somehow managed, the destination itself, Earth, is not a welcoming environment for life that didn't evolve here. The combination of these factors creates a kind of natural barrier, not an absolute impossibility, but something so impractical that it effectively prevents regular contact. And that's the key idea. It's not that alien life cannot exist. It's that visiting Earth physically, in the way people imagine, doesn't make sense under the known laws of the universe. If intelligent life exists elsewhere, and there's a strong scientific case that it is likely separated from us not just by distance, but by these fundamental limitations. Each civilization, if it exists, is probably confined to its own region of space, exploring locally, using resources close to home, and observing the universe from afar. This doesn't make the universe empty. It makes it quiet. And that quietness can feel unsettling. It leaves room for speculation, for stories, for interpretations that try to fill the gap. UFO sightings, unexplained phenomena, and unusual observations become pieces of a puzzle that people naturally try to solve. But when we apply careful reasoning, when we look at the physics, the biology, the probabilities, the puzzle starts to resolve itself. Not into something extraordinary, but into something consistent. We see that the lack of evidence is not a mystery that needs a hidden explanation. It is exactly what we would expect if interstellar visitation is as impractical as it appears. And that brings us back to where we started. The belief in alien visits is powerful because it's compelling. It offers excitement, mystery, and the possibility that we are not alone in a very direct way. But reality doesn't need to match that narrative. The universe can still be full of life and yet completely silent when it comes to direct contact. So when you hear claims about UFOs, secret programs, or hidden alien encounters, it's worth asking a simple question. Does this fit within what we know about how the universe works? Because once you understand the scale, the cost, and the risks involved, the answer becomes clearer. We are not being visited. Not because we are unimportant. Not because we are being ignored. But because the universe itself makes these visits extraordinarily unlikely. And that doesn't make our situation less interesting. If anything, it makes it more meaningful. Because it means that if we ever want to find other intelligent life, we won't be waiting for them to arrive. We'll have to go out and find them ourselves.